Okay, let's see one formula to compute the flux. When you are doing, for example, the graphic parameterization, immediately you convert this surface integral in double integral. The vector field you suppose is PQR. The normal vector in graphic parameterization is gx, comma, or minus gx, whatever. The orientation is not important. Minus gy, comma 1, divided by magnitude is gx squared plus gy squared plus 1 squared. This is a normal vector. This is a normal vector. This is a vector field. And finally ds. ds is the magnitude, I suppose this is scalar, is square root gx squared plus gy squared plus 1 dx dy. This is ds. And this is cancelled. So what is the formula? The formula is double integral of the PQR dot product, of course, minus gx, comma, minus gy, comma 1 dx dy. You perform. Okay, now you perform the dot product. So we have minus p gx minus q gy plus r dx dy. And the region D, I forgot to say, is the shadow. So the shadow on xy plane of the function c equal g in x comma y. Okay, this is the formula. Okay, in this problem compute the flux of this vector field on this surface. This surface is a compound surface formed by cylinder bounded by 0 and 3. So we have 3 surfaces. We have one first surface, this I call x1. We have another second surface, is the bottom part, I call s2. And finally, the most important surface is the lateral surface, I want to call s3. Let's compare one by one the flux. Okay, and the surface number 1, I can see the uninormal vector. I can see the uninormal vector is k. Is vector 0, 0, 1. So when you perform the dot product between the vector field and the uninormal vector, it's obvious that the answer is just c squared, because 0 times this is 0, 0 times this is 0, and 1 times this is c squared. Okay, so you are doing the surface integral and the surface s1 of the function c squared ds. But the problem is that in the surface 1, c is a constant, is 3, and 3 squared is 9. 3 squared, 9 is a constant, and actually we have the surface, that is the area, and the area, so actually this is 9, the the area, no? And the area of the circle is, well, the circle, the radius 2. Entonces 9 pi multiplication by 2 squared, therefore 36 pi. Okay. This is the flux in the first surface. In the surface 2, the unit vector is like that. Is negative k. K is 0, 0, negative 1. When you perform the dot product between the vector field and the unit normal vector, the answer is minus c squared. And the flux is the surface integral in x2 of the minus c squared ds. But the problem is that in this part c is 0. And si c is 0, it's obvious that the answer is 0. We have no flux in the bottom part, according to this vector field. Okay, and the surface 3, que is the lateral surface of the cylinder. I propose using the formula, no? The formula say que this surface integral in S3 of the x dot m ds is equivalent to the double integral in the region D of the minus p gx minus q gy plus r dx dy. Entonces I convert surface integral to double integral. Es obvio que if our surface is cylinder, x squared plus y squared equal 4, gx is 2x, gy is 2y. Now we set up the double integral in the region D. Minus p, p is this, pqr, pqr. P is minus 4x times 2x, que es gx, minus, well actually is minus 2y squared times 2y. Entonces I forgot to say here que gz es 0, no? We have no. Okay, entonces r, que r is c squared times 0. Dx dy. Okay. So we have double integral. This is minus x squared plus 4y cubed. Y cubed. Dx dy. But the domain for this double integral is shadow, and the shadow is in this case the circle with the radius 2, and the shadow is the circle with the. So in this case it's much better working this double integral in polar. So the r vary from 0 to 2 and theta vary from 0 to pi. And we change this to polar in order to compute the double integral. Okay. So it's double integral. You replace, this is minus a. But this is r squared cosine squared theta. No x, no y. Plus 4 y cubic is r cubic sine cubic theta. Multiplied by the r dr d theta. R dr d theta. Well, it doesn't matter the order. R vary from 0 to 2 and theta vary from 0 to pi. You know, it's important, the order. Very, very important. This is r first, theta second. R first, theta second. This is complicated integral. We're solving in decimals, and the answer is minus 32 pi. Entonces, what is the conclusion? What's the total flux? We manipulate in 3 surfaces. The first surface, the flux was 36 pi. In the surface 1, the flux was positive, 36 pi. In the surface 2, the flux was 0. In the surface 3, the flux was negative. The flux was negative 32. Therefore, the net flux in this closest surface is 4 pi. Addition everything. Okay.